All right, good morning. I'm away sick today, but I've made this video so that way you guys can keep learning even though I'm away. And so that way you understand what the task I've left you for your with the reliever. So first off, what I want you guys to do is your weekly check-in. So for week number 9, recap what you learned last week, set yourself a micro goal, and the random question of this week is a hot dog a sandwich? Defend your choice. The other thing I need you to do is write down today's date. Today is the 20th of September, and the learning intention, which is explore how current behaves in a series circuit. So this Edpuzzle is going to now pause so you can do those two things. All right, so let's move on and talk about the plan for today's lesson. First off, you are going to complete the drawing of the circuit diagram worksheet. And then secondly, you're going to do the current in series worksheet. It is one worksheet that the reliever should have given to you, and it is double-sided. I should say the reliever is going to collect these worksheets at the end of class, and you get an engagement point for each side being completed, plus your do now, so 3 engagement points for this lesson. But before we move on to that first worksheet, let's talk about our weekly Fakatoki, which is a little is better than none. If you find these worksheets difficult, please be mindful that getting a little bit of it done is better than not getting any of it done at all. All right, so let's first look at the worksheet. Oh, hello. All right, so this first worksheet here is listing out the rules for drawing diagrams. First thing I need you to do is write your name down here, so that way when the reliever collects it, I know who has completed what. The following rules for drawing circuit diagrams in the image, the following are the rules for drawing circuit diagrams. In the image below, I want you to circle the mistake that you see and number it as well, so that way we have evidence of the rule and what not to do, basically. So these are the 6 rules. I have done number 6 for you, which is diagram should have perpendicular 90-degree corners. So that I see is curved, so that is not a corner. So that's what I want you guys to do first. So here is your drawing. Those are your 6 things. We've already done number 6, so I want you to do 1 through 5. So again, this Edpuzzle is going to pause so you can go through and label them. All right, let me go through the answers so you can check them. So first off, all lines must be ruled and straight. We can see kind of here, for example, that that's kind of squiggly. So we want straight lines drawn with rulers. Correct symbols need to be used. So there's some incorrect symbols there. First off, that's not how we show batteries. We show them as big line, little line, big line, little line, and then connect them up. See ya. The other thing is that these light bulbs aren't being drawn correctly. They shouldn't have a line going through them. It should just be a circle and an X. So that's the other thing. Third one is no overhangs of lines. This is an example of an overhang. There should be no gaps. Here's an example of a gap. And components should not be drawn on the corner. So here's a component that's drawn on the corner. So those are my 6 mistakes in my example drawing. Now what I want you guys to do is to draw that circuit correctly. So once again, the Edpuzzle is going to pause to give you a chance to draw that, and once it is drawn, you can continue the video and get your answer checked. All right, so here is how you should have drawn that circuit correctly. Like I said, we know that some of the symbols needed to be fixed. and we're drawing things with straight lines. I highly encourage you to use rulers, but I'm mindful that you may not have a ruler on hand. So long as the lines look reasonably straight, I will take them. Now, since that light bulb can't be on a corner, we're gonna put it in the middle of that line there. And we're gonna do a corner there. This is actually a little bridge. And we see how when I'm drawing my light bulbs, I don't have the lines going through them. There we go. So that's what you should have gotten for your circuit when it's drawn correctly. So nice straight lines, no overhangs, correct symbols being used. All right, cool. So that is our first worksheet done. The second worksheet is using the PhET software. So there's several different things that we want to do with the second worksheet. The first thing is making some observations and drawing circuits. So what I'm going to do is I'm going to show you using the PhET software what each one looks like, and I want you to state your observations, and also you should now know how to draw the circuits, but I'll probably draw the first circuit for you just to kind of help you along. So here's the PhET software. So first thing I'm going to do is I'm going to connect one light bulb to a power source, which is my battery. And again, I'm trying to do it nice and straight just to kind of mimic what we have seen elsewhere. All right, so that's my first circuit with one light bulb. What I might do actually is I will leave the observations for you to write, but I will draw the first circuit to help you, so that way you know what the circuits are supposed to look like when you are drawing them. So in this case, we have one light bulb. So I'm just drawing a circuit like that. Obviously, when you draw the other two examples, you're going to be drawing it with multiple light bulbs. I'm happy if you want to put all the light bulbs on the bottom line, or if you want to spread them out so that way one's there and one's there. That doesn't bother me. But we'll leave the observations so you guys can kind of see what's going on. All right, so let's make another circuit. In this case, the circuit is going to have two light bulbs and one battery. There you go. So two different circuits, both in series. This one only has one light bulb, this one has two. Going back to the worksheet that I want you to fill in, now what I would like you to do is make your observations for the first, just one light bulb, and then an observation for now that we have two light bulbs. So we're looking, like I said, at that video here. I'll just kind of let that play for a little bit so you can have some observations. You can look to see how the light bulbs are behaving, how the electrons are moving, which are these little guys. And then the other thing I want you to do is draw the circuit for this second one here. And you can use that first one as an example. So what I'm going to do is I'm going to, again, have the Edpuzzle pause so you can write your observations for these two circuits and draw the circuit for this one. Okay, let's now go to the third one. So the third one wants us to connect 3 light bulbs to a power source. So let's do that. 1, 2, and 3. We have, again, our power source, our wire. That's what I want to do. Wire, 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 wire. And then just making sure I connect them properly. Oh, not connected properly. It was jumping. I wasn't actually getting it to touch that third wire, or third light bulb, sorry. There you go. All right, cool. There we go. We now have, oh, actually let me delete that and get that spread out a little bit further so we can actually see all 3 of them properly connected, because we don't want to have things on corners. So that's why I'm adding some wires. There we go. All right, so this is looking at this last one here, connect 3 light bulbs in series to a power source. I've done that. We have 3 light bulbs. Again, I want you to make some observations, and you can compare the 3 light bulbs to the 2 light bulbs to the 1 light bulb. So what do you notice when you see that an additional light bulb has been added? And then the other thing I want you to do is draw the circuit for that as well. So the Edpuzzle will pause to give you some time just to draw and make some observations. All right, so now we have to have a conclusion. So we're stating our trend that we notice happening to this. So what we notice in this first example is that light bulbs connected in series, or I should say, with each additional light bulb connected in series. Series is the example that we're looking at, so everybody is in one circuit. The light bulbs become dimmer with each addition. So in a series circuit, with only one pathway, each additional light bulb makes all the others dimmer. So that's the trend that we notice in a series circuit. I'll put a video pause in here as well, so that way you can copy down that conclusion. All right, now on to part 2. We are looking at current. So when we are talking about current, we are talking about the flow of electrons. Just FYI. So let's see if, sorry, the way we measure current is through an ammeter. So ammeter is how we measure, is measured. And the way we annotate that we have an ammeter is by an A, like that. Cool, so I am actually going to get rid of all these things. Let's just actually start a new circuit sheet. All right, so in this first question, what I want to do, we're looking over at the list, it says connect a light bulb before the ammeter and plug it into the power source. So I want to go ammeter, which is this guy here, light bulb, and I want to measure current. just gonna make that a little bit longer. So that way, again, my ammeter is not on the edge. Like that, and like this. So this is what I have set up. Did I say before or after? Before the ammeter, sorry. Connect the light bulb before the ammeter. So this should actually be the other way around. So the ammeter is before the light bulb. Sorry, let me just delete that. So I'm gonna actually get this going properly. Just gonna make these guys a little closer, and that can go down there. All right, there you go. So that's our setup. We have our ammeter, which is measuring the current. Current is the flow of electrons, which are these guys here. And so it's just measuring to see how quickly those electrons are moving. Now, something to note is that ammeter needs to be put in series, so it needs to be in the line of the pathway of where those electrons are moving. So, what's the current? It's 0.9 amps, and I'm going to draw the circuit. So with my circuit, we had a light bulb. Here's my ammeter, and we'll draw it all together like that. All right, in the second example, what I want to do is swap them around. So I'm going to put the light bulb after the ammeter. And what I'm trying to do is see if the location of that ammeter makes a difference. So I'm going to delete that. I'm going to delete this, and we're going to swap them around. The light bulb is going on this side, and the ammeter is going before it, like that. There we go. Try to wedge you. Okay. So this is the ammeter before the light bulb. We'll make some observations on the number. So I want you to write down the number that you see and also draw that circuit as well. So I'll leave this up so you can see it. And right now I want you to write the current and draw that circuit. And I'll let the video pause again here so you can do that. All right, so last question here is, does the location of the ammeter matter in a series circuit? Why or why not? The answer is no, it does not matter when it comes to a series circuit, because we are just trying to measure the flow of electrons, which can be done anywhere in that circuit. Cool. So no, because ammeters measured the flow of electrons, which is also known as our current, which can be measured anywhere in the circuit's pathway. So it doesn't matter if it's before, if it's after, it's still going to register the same number. So again, I'm going to make the Edpuzzle pause here, so that way you can copy that down. All right, last thing we then are going to be doing is the connections of more light bulbs, and in this case now we're actually going to be putting the ammeter just to see what is happening with the current. So if we go back to this example here, we notice when we're looking at these three that the observation that I have is that every time I add a light bulb in series, the light bulb gets dimmer. Now, something else that you may have noticed is that these electrons here are moving slower with each addition of the light bulb. Let's actually test this to make sure that this is true by putting in some amp meters. So once again, I'm going to delete some of these so that way we can fit in our amp meters. Now I'm going to be annoying and just put it there. All right, so with that amp meter connected up, we notice that it is 0.9, which is what we had before when we were looking at this one over here. Now I'm going to add an amp meter to this one that has 2. And I want you to record that number in your worksheet. Over here, what is the current? And the last one here, we will put down. And again, I want you to write that number down here. What is the current? And from there, I want you to make a conclusion of what you noticed happening. What you can also state in your conclusion is you can look at how these numbers relate to each other. So 0.9 compared against 0.45, 0.9 compared to 0.3 to see if you can figure out what's going on every time I add a light bulb, and to see if that then correlates with some of the other trends that we see. So that is the end of this video. So you should be filling in this conclusion here. And once you are done, you should be handing that to the reliever to collect for your 2 engagement points. If you have finished this before the end of the period, there is an extension worksheet that you can do, which is this one here. And that has you practicing drawing circuits and also testing if you understand the concepts of what's going on with the amp meter and how we measure it. So be mindful that we've given you an amp meter reading in one location using what we know already about amp meters and series circuits, thinking back to that second example on that worksheet, part 2, what should the measurements be? So that is your extension worksheet. So I hope you have a good day. If you, again, still finish early and you have some extra time left over, I believe there's still that Magic School Bus as well if you want as your kind of final thing to do. But to recap today, what you should be able to do is explore how current behaves in a series circuit. You should be able to have some observations about light bulb brightness and current. We haven't talked about voltage yet, but we will in a few lessons. And in particular, how it works in a series circuit. And then you should also be able to draw and make circuits. The making of the circuits we'll be able to do in another lesson when we actually take out the equipment when I'm there. All right, hope you have a good day.